Hello everyone, my name is James Nrenda. I'm representing part of our research group that did this work on acetone crude extract of cashew nut shell as a potential for control for armyworms. I work for the University of Zambia, School of Natural and Applied Sciences, Department of Pure and Applied Chemistry. So I'm the lead researcher for the Plant Natural Products Research Group. For this talk, this is the outlay of my presentation. We'll look at the introduction, statement of the problem, significance of the study, the main aim, specific objectives. We'll look at salient literature that was cited, the methodology used. We'll look at results and part of the discussion, as well as the conclusion. And of course, acknowledgements and various references will be shown. Now, for armyworm is essentially an insect pest that attacks maize. And within the Zambian context, maize is a staple food, and anything that tampers with the growth of maize institutes food security threats. And we can see that the fall armyworm has potential to damage literally the whole plant, including the maize cobs that are produced from the plant. For example, in panel A, we can see the leaves being damaged. In panel B, the tassels being damaged. In panel C, the maize cob itself being damaged. And of course, when we look at panel D, the yields are very low, and also quality of the maize harvested is very low, and ensuring that food security is threatened. According to Matthew Mutan, 2019, the fall armyworm is being likened to a pandemic. And since it's a pandemic, like the COVID, we are looking at food security doom. So when we look at the current scenario of control or management of pests, a lot of synthetic insecticides are used, and to control the fall armyworm in Zambia, extremely poisonous insecticides have been used. For instance, monocrotophos, methomyl, as well as profenophos have been listed as highly hazardous by the World Health Organization, but these have been used to try to control or manage the fall armyworm in Zambia. Again, the other problem is that overdependence of the synthetic insecticides is showing pests developing a resistance, as has been reported in Brazil. So to counter this problem, we are thinking of the botanical insecticides, knowing that botanical insecticides have got a clear biosynthetic pathway where we've got synthesis taking place, and also particular breakdown is known. We see that most of the botanicals don't leave extremely toxic residues after use. So this study is trying to promote such integrated pest management system using botanicals. So our aim was to extract, characterize, and evaluate the larvicidal, ovicidal, and feed-and defects of the crude cashew nut shell liquid against Spodoptera frugipeda, J.E. Smith, which is the common name called the fall armyworm. So the specific objectives included extraction and characterization of the cashew nut shell liquid, CNSL, from the cashew nut shell wastes that are obtained from Mongo district, Western province, where cashew nuts grow well in our country. The next specific objective was to evaluate the insecticidal properties of the extracted cashew nut shell liquid. And in this case, we're looking at effect on the larva, effect on the eggs, as well as effect on the feeding patterns. The last objective was to determine the lethal dose, of course, of crude cashew nut shell liquid against S. frugipeda. Some of the questions we asked ourselves is, what is the chemical composition of the CNS extracted from cashew nut shells obtained from cashew nut grown in Mongo district, Western province of Zambia? The reason why we're asking this question is that We know plants have got a hydrogeological effect. The metabolites follow some hydrogeological pattern. So we may not know exactly what chemical composition of CSNL from a Zambian perspective. The other question is, does the CNSL have insecticidal activity against for armyworm? Briefly, we can see the uses of cashew nut shell liquid. Cashew nut shell liquid is applicable in many particular fields, in the material sciences, in the paint industry, but our major focus is to look at the particular application of cashew nut shell liquid as forms of bactericides, as form of pesticides or fungicides, as well as agroveterinary agents. So this is essentially what our focus is about, looking at the phenolics, the properties of the phenolics in the cashew nut shell liquid. Are they able to offer insecticidal properties, as well as other properties of importance? So the question is, why use cashew as an insecticide? Research has shown that cashew is quite rich in phenolic lipids, and some of these phenolic lipids are of importance. And so this was just to show the process from the cashew tree, which is Anacardium occidental. We get the cashew fruit, then from there we get the nuts. The nut, of course, the kernels are eaten, and the shell, for Zambian perspective, is a waste. And so we thought of adding value to this waste, so that if we extracted cashew nut shell liquid, characterize it, and apply it as an insecticide, we can add value rather than having the shells going to waste. So the methodology follows that pattern. We did sample collection, of course, and then we raised 4 armyworms in our agricultural research labs, and these were reared under controlled conditions. And of course, for the particular preparation of cashew nut shell liquid, we used solvent extraction methods. And in the characterization, we looked at phytochemical screening, then chemical composition, and other physicochemical properties of our Zambian obtained cashew nut shell liquid. We also carried out toxicity studies. In this case, we looked at antioxidant properties of the cashew nut shell. We also looked at larvicidal properties. We also looked at ovicidal properties to ensure that we see the effect. And for all this, in terms of the larvicidal properties, we also relied on histology analysis. Of course, the data collection and statistical analysis was performed. Then we made some conclusions. So when you look at the results we obtained, we see that cashew nut shell liquid is rich in phenols, and we characterized these in ethanol. We also characterized them in methanol. We characterized them in acetone, and we also looked at chloroform and hexane. So we looked at total phenolic content and total flavonoid content, and this is shown in panel D, where we have acetone showing higher yields of total phenolic contents, and the phenolic content in acetone extracts was now used to characterize insecticidal properties. When we look at the phytochemical screening, the cashew nut shell liquid extract had carbohydrates present in all the particular solvent systems, the aqueous, ethanol, acetone, and hexane. Proteins were not isolated in aqueous, but were present in the ethanol, acetone, and hexane. We also had phenols, which were present literally in all solvent systems, but much more in organic solvent systems. The alkaloids were absent in the aqueous, but we could isolate them in ethanol and hexane as well as acetone. Saponins were present in all solvent systems. Flavonoids were present in all solvent systems. Steroids were present in all systems, but terpenoids, glycosides were absent in the aqueous, and glycosides were also absent in the acetone. Carboxylic acids were present in all solvent systems. The single plus sign just means present. The double plus sign, double or triple plus sign just shows presence in high amounts. The negative sign means it's absent. Then we went ahead to characterize the particular cashew nut shell liquid. So we look at table 2, that has physicochemical properties of the cashew nut shell liquid. The color was consistent with literature that we searched. It's dark brown, and for the literature we looked at Ida P. et al. That's 2014 paper. Odor, it has a choking feeling. Then the nature in terms of viscosity, the Akinhani paper was used to compare our extracted cashew nut shell liquid. Moisture content in terms of percentage was about 6.5. Was that reported in literature was about 6.7. Ash content percentage wise was 1.6 plus minus 0.1, and that was whatever was recorded in literature is about 1.3. Specific gravity at 30 degrees Celsius was 0.956, whilst that reported by Mohammed in 2015 was 0.9995. Refractive index at 20 degrees was 1.52. In literature, Akinhamni is 1.686. Viscosity at 24 degrees Celsius was 104.6. Less viscous than what was reported by Rodriguez, 150 to 600. Acid value in terms of milligrams potassium hydroxide per gram of sample was 118. Was that reported in literature by Archie et al. As well as Mahanwa and Kale was 141 and 112 respectively. Free fatty acids was about 60, and that reported by Akinhamni, that's about 58. Saponification was about 138, whilst that which was reported by Aki et al. Was 161. So the iodine value was 188, and that what is reported by Aki et al. Was about 177. pH was about 3.2, and that which was reported was about 3. So we can see that most of our physicochemical properties of cashew nut shell liquid fall within the range of what has been studied elsewhere, and this also just gave us some confidence that what we extracted was closer to what has been reported elsewhere. So when we look at the FTIR analysis of the crude cashew nut shell, of course, we see peaks at 34.14 per wave number, and as well as 12.05 per wave number. This is indicative of the phenolic OH stretching, and the 3008 wave number. This is the CSP2H aromatic stretching, and 29, 26, as well as 28, 52. These are aliphatic CH, that's SP3 stretching. 1607 to 1450, that's aromatic CC double bond stretching. 1648 to 1605, this is for alkanes stretching. And of course 990 to 910, these are alkenes with the RHC CH2 angular stretching. So this again was confirmed using the literature by Furtado et al. As well as Das et al. And so this again characterization give us more confidence that at least what we are working with is the actual compound that has been characterized elsewhere. We also carried out TLC analysis of the crude cashew nut shell liquid. We could see that at 254 nanometers, there were two intense bands. 366, again, we could clearly see two intense bands. Then the the first blue dye showed three important bands we are going to explain, and then of course iodine vapor showed more than four bands that are of importance. So we could see that what we were looking at for the TLC was that at RF retardation factor 0.74, this was cardinal, and then the retardation factor at 0.47, this was for anacardic acid, and of course the one at retardation factor 0.24 was cardinal, and this again was confirmed with literature by Timon et al. That was in 1989. Then we also carried out GCMS analysis of the crude cashew nut shell, and we could isolate ions. The total ion chromatogram, as shown, shows that the chemical compositions were that at peak number 1, the retention time of 19.08 minutes, that was the CADOS in the saturated form. Retention time 19.79, that's peak number 2, that was the CADO die-in that was identified. Then retention time of 30.35, that was cardinal with 13 carbon atoms. And the peak at number 4, retention time of 32.76, that was cardinal with 15 carbon atoms. And of course the peak at the peak number 5, retention time 35.64, that was cardinal, again with 17 carbon atoms. So we could see that the composition was that cardinal was about 15.2%, cardinal was 79.5%, and the other hydrocarbons were about 2.35. Some unidentified compounds made up this mixture of about 2.62%. So these are other peaks for the particular resolved mass spectrum. Of course, fragmentations were also identified, and we could look at beta cleavage in terms of the archeobenzenes. That's similar to what we observed. So we could see that our fragmentation pattern was following the beta cleavage in what we identified. So we could see that what we were obtaining is the study in place where we could identify that cardinal was fragmented appropriately. In terms of toxicity of the cashew nut shell liquid against 4 armyworm eggs and larvae, we could see that the particular cashew nut shell liquid had a concentration effect. So we could see that The cashew nut shell liquid at 1% was less effective, whilst the cashew nut shell liquid at 7% was comparable to cypermethrin, the synthetic pesticide that was used. And we could see that the lethal concentration at 50% at 95% confidence limit was interval was 2.5, that is 0.22 to 4.02 weight by volume percent, with a p-value of 0.001, very significant. Whilst the larval mortality was about 1.92 with a range of 1.71 to 2.15 with a p-value of 0.408 after 2 hours of treatment. So we could see that the particular 4 armyworm eggs and larvae were able to be destroyed. So we could see that the crude cashew nut shell liquid had a very good activity, both toxicity on the eggs, the ovicidal effect, as well as toxicity on the larvae, that's larvicidal effect. The histology showed that the larvae that were not treated with cashew nut shell liquid showed an intact cuticle. But when we applied the cashew nut shell liquid on the larvae in panel B, for example, the histology showed in panel D shows that the cuticle was detached. This may ensure that the particular membrane of the larvae was affected, and this contributed to what we alluded to as topical toxicity. Yeah. Again, antfeedant effect of cashew nut shell liquid showed that 5% and 7% were comparable to nimbecidine, which is on the market, and we could see that the EC50 was about 0.34, far much better than the EC50 for 1.46 weight by volume for nimbecidine. So we could see that cashew nut shell liquid may have potential as an antfeedant applicant on the maize plants to just deter the particular worms from eating the maize plant. So in conclusion, we see that we positively extracted cashew nut shell liquid from the particular shells that were waste, and then we characterized them, we optimized the solvent system, and we found that acetone was better placed. And of course, the chief chemical compounds in the cashew nut shell liquid were archaeophenolic lipids, cardanol and cardo respectively. Of course, the toxicity studies showed that cashew nut was toxic to 4 armyworm eggs as well as larvae, and also demonstrated the antfeedant effect. This suggests that cashew nut can be exploited as a fairly cheap, safe, and eco-friendly alternative insecticide for managing S. frigipeda outbreaks in Zambia and across the world. Some of the recommendations we make is that we look at phytotoxicity of cashew nut shell liquid on maize should be conducted so that we do not transfer the toxicity to the humans. And above all, 6% were reported to affect soybeans plants. So we need to study this further. And also, this study was laboratory controlled. We recommend that field trials should be conducted to see if the cashew nut shell liquid will show the same efficacy as it showed in the laboratory trials. These are some of the people that helped. Mr. Gilson Chipavika, who works for the Zambia Agricultural Research Institute, Mount Makulu, Mr. Chipo Siabamba, Mr. Adolf Lungu from the University of Zambia, of course, School of Agricultural Sciences, School of Veterinary Medicine, Department of Biosciences and Biotechnology, Department of Pure and Applied Chemistry. We also have the Kasisi Agricultural Research Institute for supplying us with NIM, the Ministry of Education for supplying Mr. Kadango with a scholarship, as well as the International Science Program, Uppsala University in Sweden, for providing funding for the ZM02 natural products research. Thank you so much. These are some of the selected references. Thank you. God bless you.